So this question regarding the implicit function theorem, the extension of the theorem. So when do we use the Jacobian matrix? So we use the Jacobian matrix if we have a simultaneous equation. So we have more than two equations. So here we have three equations. So we use the Jacobian matrix, and when we have more than two variables, so we have here 1, 2, 3, and 4 variables. And you must remember that here x, y, z, x, y, w, they are dependent variables. Z is the independent variable. Okay, so what does this mean is that we have to find out what happens to x, y, and w when z changes. Okay, this comma here, it means that z is the independent variable. So we have to find out what happens to these three variables x, y, w when z changes. What happens to x when z changes, what happens to y when z changes, and what happens to w when z changes. So that is the meaning of comparative derivative. Now we compare the variables. So this is the question given to you, three equations, and they are satisfied at point x 1 by 4, y is 4, w is 1, and z is 1. So first thing first, what we have to do is we have to find the total derivative of each equations. So you write finding the total derivative. I won't write this, there's no space here. So finding the total derivative of each equation with respect to x, y, w, and z. So let's take the first equation, the first equation f1, which is this. So here we derive with respect to x, with respect to y, with respect to w, and with respect to z. So taking the total derivation. Alright, so here we have x and y. Now you must look carefully. Who are the variables? X, y, w, z. X is a variable, y is a variable, w is also a variable. Inside this bracket, it means they are all variables. So these are all variables. So we derive all these. So first we derive this x. Now here it's a product, so we must use the product rule, and we know that the product rule is derivation of the first. ddx of x is 1 into the second, and we derive this with respect to x, right? dx plus derivation of the second, dy of y is 1 into the first. We derive this with respect to y, right? dy minus w is also a variable, so ddw of w is 1 with respect to what? We derive it with respect to w. Simplify this will be y dx plus x dy minus dw is equal to 0. This is your first equation. Alright, now for the second one. Y, this is also a variable. Derive this. dy of y is 1. We derive with respect to y, right? dy minus w cube. This will be dw of w cube will be 3w square, right? dw because we derive with respect to w, minus 3 is a constant, take it out, so ddz of z is 1, so 3 into 1 is 3, is nothing, and we derive this with respect to dz. This is your f2. Now for the third one, this will be 3w square. We derive it with respect to w, right? dw plus this will be cube 3z square. We derive this with z, right? dz minus this is 2 here is a constant, take it out, and z and w they are variables, so we have here a product rule. So we derive using the product rule. Derivation of the first is 1 into the second, right? dz because we derive this with dz plus derivation of the second, which is w, which is 1 into the first, z, and write dw because we derived this with respect to dw. Now simplify this. This will be 3w square dw plus 3z square dz minus, simplify this, you'll get 2w dz plus 2z dw. Now we can further simplify this, putting all the dw's in, collect them all together, dw and dw, put them together, so we have 3w square dw plus 2z dw. Now dz is left, 3z square dz minus 2w dz. Take common dw here. Here we have dw, 3w square plus 2z. Take common dz. We have 3z square minus 2w. And this is your third equation. Okay, so now this was the original function, the original equation. Now we have turned it into this. The first, it becomes this. The second, it becomes this, f2. The third becomes this after taking total derivation. Now in place of these, we will write with these new equations. Okay, so you will get, I'll drop this. So you'll get y dx plus x dy minus dw is equal to 0, dy minus 3w square dw minus 3dz is equal to 0, and the last one is 3w square minus 2z dw plus 3z square minus 2w dz is equal to 0. Alright, so our next step is to take all the coefficients of the total differentiation, or the coefficients of dx, dy's and dw's. Take all the coefficients. The coefficient of dx is y, dy is x, dw is nothing here, it means 1 minus 1. Taking all the coefficients and writing them in matrix form. Okay, or we can do this first. Before putting in matrix form, let us put the dependent variable on the left side and independent variable on the right side. Now remember, I told you z is the independent, so anything that has to do with z, we keep them on the right side, the rest we keep on the left side. Okay, because we have to find what happens to x and y and w when z changes. So these three, they depend on z, so z is the independent, keep z on the right side, all these on the left side. So you look here, there's no dz here for the first one, so write as it is. Here we have dz, so this dz, take it to the right side. So we have dy minus 3w square dw is equal to, carry this, it becomes plus 3dz. Here we have dw and dz. This dz, carry it to the right side. So we have 3w square minus 2z dw is equal to minus 3z square minus 2w dz. Simplify this minus sign. Here we'll have minus 3z square plus 2w. So I'll write 2w first because it's positive, minus 3z square dz. Alright. Now after this, we write in matrix form. Okay. So the matrix form, remember, it's AX is equal to B, right? Where A is the coefficient matrix, X is the variables, and B they are constant. So write it in that form. So the coefficient matrix, who are the coefficient? Y, X, nothing here means 1, right? The coefficient of all the total differentials. So for the first one, the coefficient of the X is Y, right? Y. Coefficient of the Y is X, put X. Coefficient of dw, there's nothing here, it means 1, so it's minus 1. For the second, here we have no dx, right? It's only dy, so which means it's 0. For dy here, it's 1, nothing there means 1. For dw, we have minus 3w square. And for the third one, do we have dx? No. Do we have dy? We don't have for dy also, we have for dw. For dw, the coefficient is 3w square minus 2z. Square minus 2z. We have write this in matrix form, and there's no space for me. This, for the first one it's dx, for the second it's dy, and for the third is dw. Is equal to, now whatever is on the right side. This should be here, okay? There's no space for me, I'll write it down here. Should continue this side. Continue this side here. For the first, it's 0. For the second, it's 3. Coefficient of dz is 3. And for the third, the coefficient is 2w minus 3z square. Okay. So, since we have to find what happens to x, y, w when z changes. Now remember, this right side represents z. This right side, this is right side, it represents z. So in place of this y00, I will rewrite it with this, okay? Because I want to see what happens to x, y, w when z changes. So that's why I take this and I substitute it here. So in place of y, this will come here now. In place of y is 0. The rest is the same. In place of 0 is 3 because I took this and put it here in the first column. 3, 1 minus 3w square. In place of 0 is this. 2w minus 3z square. We have here 0 and 3w square minus 2z. Alright. Divided by the Jacobian matrix. Alright. So, now we have to find what is the Jacobian matrix. Here we can just substitute the value of x, w and z. Alright, so you do it by yourself, so I'll just write the answer. What is the values here? This will be 0, this will be 1 by 4. Value of x is 1 by 4, minus 1. 3, 1 minus, value of w is 1, 1 square is 1, so 3 into 1 is 3. So if you calculate this, you will get minus 1. Then it's 0. To calculate this, put the values here, you'll get 1. Divided by the Jacobian. Now the Jacobian here, this is nothing but the determinant of the Jacobian. So all you have to do is find the determinant of this whole thing. You will get the answer. But if you look here, look at this one carefully. If you look here we have an upper triangular matrix. If you look at this carefully, the matrix below the diagonal, they're all zeros, so this is nothing but an upper triangular matrix. So for this, what we have to do is just take the diagonal y, 1 and 3w square minus 2z, take the product of this, okay? The Jacobian will be nothing but, right here on the side, I'll erase this. So how to find the Jacobian? This value g here. This is nothing but the determinant of this. Okay, you find the determinant, you'll get the Jacobian. But in this case, here we have an upper triangular matrix. You just take the diagonal matrix, and the Jacobian is nothing but the product of these three. So it's y into 1 into 3w square minus 2z. Okay, this is only if it is an upper triangular matrix. If it's not an upper triangular matrix, then what you have to do is just find it regularly using determinant for this. So what is y? Y is 4. Right, y is 4. This is 1. 3w square minus 2z. Here we get this is nothing but 1 only. W square is w is 1. So 3 into 1 is 3, minus z is 1, 2 into 1 is 1, 2 into 1 is 2, so 3 minus 2 is 1, so we get 1, which is 4. So this here thing is 4. Okay, that's 4 only. So next, find the determinant of all these here. So find all the determinants. And if you find it now here, since we have to find the values of z, what happens to z when what happens to all x, y, w when z changes. So we will take with 0, 3 and minus 1 as the determinant, not in the regular case like the first row. We'll take the first column because we have substituted the values of the first column here, the original one, with the z values 0, 3 and minus 1. So we'll take here 0. Remember, cover this first row and first column. You have 1 minus 3, 0, 1. So it's plus 3. Cover the middle one and the first. We have here 1 by 4 minus 1, 0 and 1, 0 and 1. And then take this plus into minus. You have minus 1. Cover the first column and the last row. Here we have minus 1 by 4, minus 3, 1 and minus 1, minus 3. This is nothing but 4. So find 0 into this whole thing is 0 only. So 1 into 4 is 1. 1 by 4 into 1 is 1. Right, it's this into this minus this into this. So 1 by 4 into 1 is 1 by 4. 0 into 1 is 0 only. Minus 1. 1 by 4 into minus 3, we have here minus 3 by 4. Minus 1 into minus 1 is minus 1. Divided by 4. So this becomes 0 plus 3 by 4 minus 1. This becomes minus 3 by 4 plus 1 divided by 4. It becomes 3 by 4 minus 1. Find LCM. This becomes minus 3 plus 4 divided by 4. And then simplify this. You'll get, simplify this by yourself. You get 3 by 4 minus 1 by 4 divided by 4. So here you will get 3 minus 1 is, you get 3 minus 1 divided by 4. The 4, so we have 2 by 4 divided by 4. Also this will be 3 by 4, not 1 by 4. Here will be 3 minus 4. This will be 3 minus 4. Is it? No. Sorry, here will be 3 minus 4. This will be 3 plus minus 3 plus 4 divided by 4. Yes, that's correct. This will be 1 by 4. This will be minus 1 into 1 by 4. This will be 3 by 4 minus 1 by 4 into 4. Simplify this. What do you get? this will be 3 minus 1 divided by 4 into 4. So here you have 2 by 4 divided by 4, 2 ones to 2. Here we have 1 by 2 divided by 4, which is nothing but 1 by 2 is 0 0.5 divided by 4. So that is the answer. That is